Hello everyone, my name is Muhammad Takif bin Idris and my pair is Edwin Farhan. Okay, today we'll break down 3 statistics problems covering confidence interval. I will guide you guys through each step. So, let's begin. Okay guys, for the first task, we need to find the distribution of 29s square divided by sigma square. A fundamental theorem in statistics states that for a normal sample, the quantity n minus 1 times s square over sigma square follows a chi-square distribution with n minus 1 degrees of freedom. Since our sample size n is 30, the degrees of freedoms are 30 minus 1, which is 29. Therefore, the distribution is a chi-square with 29 degrees of freedom. Next, we construct the 95% confidence interval for the standard deviation. We set up the interval formula using the square root of the variance interval bounds. The lower bound is square root of 29 times 3.2 square over 45.722. And the upper bound is the square root of 29 times 3.2 square over 16.047. Calculating this value gives us the final 95% confidence interval for sigma, which is from 2.5485 to 4.3018. To find value of x, we use the given 90% confident interval of 4.127 and 23.873. We set up two equations based on the lower and upper bounds of the interval formula. First, solving the lower bound equation, which is 150 minus x minus margin of error, which is 4.127, give a value for x of 136.8468. Second, solving the upper bound equation, 150 minus x plus margin of error, which give us 23.873 for the value of x of 135.1532. By taking the average of these two results, 136.8468 plus 135.1532 divided by 2. We find that the value of x is 136. Next, to decide if the average expenses are the same, we check if the value 0 is inside our confidence interval. A value of 0 would mean there is no difference. Since our interval 4.127 and 23.873 is entirely positive and does not include 0, we have statistical evidence of a difference. Therefore, we conclude that the average expenses are not the same.
Moving on to question 2. In part A, my first step was to calculate the sample variances. For center A, I calculated SA square equals 7.4 square, which is 54.76 for center B. I calculated SB square equal 5.3 square, which is 28.09. I also noted the sample sizes and my N1 equals 7 and N2 equals 13. And the corresponding degree of freedom, df1 equals 6 and df2 equals 12. My work then shows the derivation of the confidence interval for the ratio of two variances. I started with the pivotal quantity bracket SA square over variance A square over bracket SB square over variance B square, which follow an F distribution. I place the statistic between its two critical values, f1 minus alpha over 2 and a minus 1 and b minus 1, and F alpha over 2 and A minus 1 and B minus 1. Next, I use the identity that F1 minus alpha over 2 and A minus 1 and B minus 1 is equal to the reciprocal of F alpha over 2 and B minus 1 and A minus 1. After substituting this identity and rearranging the inequality to isolate the ratio variance A square over variance B square, I derive the final formula for the confidence interval. The lower bound is SA square over SB square times 1 over F alpha over 2 and A minus 1 and B minus 1, and the upper bound is SA square over SB square times F alpha over 2 and B minus 1 and A minus 1. For part B, I applied this formula. I substituted my sample variances SA square equal 54.76 and SB square equal 28.09. For a 95% confidence level, alpha over 2 is 0.025. I use the F critical values F0.025 612, which is 3.73, and F0.025 12.6, which is 5.37. Plugging these values into my formula, I have the expression 54.76 over 28.09 bracket times bracket 1 over 3.73 on the left and 54.76 over 28.09 bracket times 5.37 on the right. Performing this arithmetic, I calculated the final 95% confidence interval ratio to be 0.5226, 10.4685. Finally, for part C, my conclusion is based on this interval. My conclusion states, based on interval, obtained can conclude that variances are different because the value 1 lies within the interval 0.5226, 10.4685. Finally, let's look at question 3. For part A, my first step was to calculate the point estimates. For the average, I used the formula mean equals sum of x over n. I sum the 15 data points to get a total of 473.7 dividing by 15 give me a sample mean of 31.58. Next, for the standard deviation, I use the formula for the sample standard deviation S, which is the square root of sum of x minus mean, bracket it and then square over n minus 1. My calculation shows that the sum of the square differences from the mean was 9.804. I divided this by n minus 1, which is 14, and then took the square root. This is resulted in my calculated sample standard deviation of 0.8368. For part B, I found the 99% confidence interval for the average volume. I started by writing the T interval formula. Mean plus minus T bracket alpha over 2 n minus 1 times S over square root of n. In the next line, I substituted my values. Mean is 31.58 for a 99% interval. Alpha over 2 is 0.005. The degree of freedom are 15 minus 1 or 14. I plug in S as 0.8368 and N as 15. Then I look up the T critical value from the table, T bracket 0.005, 14, and found it to be 2.977. I substituted this into my expression. My next step was to calculate the margin of error by computing 2.977 times bracket 0.8368 over square root of 15, which I found to be 0.6432. Finally, I wrote 31.58 plus minus 0.6432. This gave me the lower and upper bounds for my interval, which are 30.9368 and 32.2232. This is my final answer for the 99% confidence interval for the average volume of bottle drink.